Because anthrax had never been decontaminated from an area of this magnitude before, experimental cleanup technologies had to be considered. After 8 weeks of testing at the Brentwood Postal Facility by EPA's Environmental Response Team, fumigation with chlorine dioxide gas, or ClO2, was chosen as the fastest, most productive, and least destructive process.
Although the product, the disinfectant, is used in food and water disinfection, it's used in the oil field to help get more oil out of the ground, it's never been used like this. So it's an experiment, but it's a valid experiment, and we are going to, I think, be able to show a new way to handle this kind of an assault from a biological organism.
The process required a labor-intensive layout of electrical cabling, ducting, and apparatus in the building, and sealing vents, doors, windows, and ceiling spaces in the treatment area. Here's how the process works. The gas won't be effective unless the environment is warm and moist. Steam is pumped into the suite until humidity levels reach between 70 and 80%. Meanwhile, the chlorine dioxide gas is generated in an aqueous solution outside the building. The solution is then delivered via piping to the office, where an air stripper emits the ClO2 into a gaseous state. It is then distributed in the suite using ducting and fans. The process delivers a uniform concentration and thorough treatment throughout the contaminated area, including ceiling spaces, carpeting, and furniture. 3,000 spore test strips were prepared to place in the Dashel suite to evaluate the fumigation's effectiveness.
The spore test strips are believed in some cases to be hardier than the anthrax spore, and we have known numbers of spores that are attached to these strips, 10 to the 6th, 10 to the 7th, 10 to the 8th. They're located throughout the suite in areas that we believe gas might be hard to get to. And the idea is that we want to be able to assure that we've got the destruction that we need.
Finally, on Friday, November 30th, Capitol Hill Police secured the surrounding streets, and employees in the adjoining Dirksen building were sent home early so the system could be put through its paces. By 2 a.m., humidity had reached target levels, and ClO2 was pumped into the building. EPA's Environmental Response Team performed perimeter air monitoring as a precautionary measure to ensure that the surrounding public was not at risk of exposure to any fugitive emissions of ClO2. ERT's TAGA, or Trace Atmosphere Gas Analyzer bus, also circled the site, collecting real-time air samples in the low parts per billion. During the fumigation process, chemists from the chlorine dioxide industry conducted on-site analytical tests to measure the concentrations of ClO2 inside.
Once we achieve those concentrations we're looking for, we would then go through a scrubbing process, which would simply be the introduction of a caustic and bisulfite solution being stripped through the emitter and then subsequently reacting with the chlorine dioxide in the room.
The bisulfate solution was used to ensure complete destruction of the ClO2. Finally, after 16 hours, the initial fumigation cycle was complete. Post-operation confirmation sampling and analysis revealed that additional treatment would be required to kill a small quantity of spores still remaining in the Dashel suite and the ventilation system. Teams went to work erecting a scaled-back version of the gassing system that could treat roughly 3,000 cubic feet. The revamped system could also be operated and monitored from the Hart Building's underground parking garage. On Sunday night, December 16th, the gas was circulated through the ventilation system, but was aborted the next day after saturation levels could not be sustained. After some modifications to ensure that humidity levels would remain near 75%, a final 4-day effort to kill trace amounts of remaining spores kicked off on Friday, December 28th. Along with the Dashel suite fumigation, 11 additional areas in Hart and other tainted buildings were disinfected using a variety of methodologies, such as liquid chlorine dioxide, foams, and HEPA vacuuming.